Hello everybody, in this video we are going to discuss 5 important questions on the topic real numbers. So let's start with it. So the very first question over here, it's given that let a and b be two positive integers such that this and this is given. The prime factorization of a and b is given over here where p and q are prime numbers. And you see over here the HCF of a and b is given and LCM of a and b is given. And then we have to find the value of this expression. So let's start with it. The first thing over here is these are in the prime factorized form. So what will be the HCF of these two numbers? HCF means you have to take the common factors of a and b. Common factors of a and b over here will be what? P and q. So therefore we have to take p and q over here. And then you have to take the lower power, the lowest power you can say. Obviously over here two numbers are there, so you can say lower power of p and q. So p square will come. And then in case of q, you have to take q cube. So this is your HCF. Now if you compare them, you see there cannot be any other thing because it's already, p and q are already prime numbers. So you can directly compare over here, m will be 2 and n will be 3. So over here m will be 2 and n will be 3. In the same manner, we have to find the LCM as well. So in LCM, we have to take all the prime factors in both the numbers, whether common or not. So over here, you have to take p and q. They are the prime factors in the prime factorization of both the numbers a and b over here. So obviously, p and q will come. And then you have to take the higher power. You see p cube and p square. So 3 will come. Similarly, q raised to the power 4 and q cube. So 4 will come. So if you just compare, again the same thing because p and q are prime numbers. So if you just compare over here, you can say that r is equal to 3 and s is equal to 4. So this will be 3 plus 4. So this thing over here is 5 into 7, that is 35. So you can say 35 is the answer. In the same manner, this is one of the important questions in this chapter. You have to find the least number that is divisible by all the numbers from 1 to 10, both inclusive. The least number which is divisible by all the numbers from 1 to 10, both inclusive, will be the LCM of the numbers 1 to 10. So 1 you can write as it is. This is 2, 3, 4 in the prime factorized form, 5, 6 in the prime factorized form, 7, 8 in the prime factorized form, 9 in the prime factorized form, and 10 is 2 5s are 10. Just check it once again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these numbers are already in the prime factorized form. So in the LCM of them, you have to take all the prime factors, whether common or not. So all the prime factors, whether common or not, will be what? 2, 3, and then obviously 5 will come, then 7 will come, and then over here, these are the only prime factors, 2, 3, 5, 7. These are the only prime factors in the prime factorization, whether common or not. And then you have to take the highest power of them. So you see 2 cube, and then over here 3 square, and then 5 will remain as it is, and 7 will remain as it is. So this is the answer. So you just can multiply 8 9s are 72, multiplied by 7 5s are 35. So if you just multiply these two numbers, you'll get 25 20. You can check it. If you just multiply them, you'll get 25 20 over here. Obviously, you can remember this answer as well because this is one of the important questions on this topic. Now let's try doing this one. The sum of two numbers is this and their HCF is given. You have to find the number of such pairs. So obviously if they are asking the number of such pairs, they mean that you have to find the number of such unique pairs, right? So sum of two numbers is given and their HCF is given. So we can assume that the numbers are of the form 33x and 33y. If you assume over here that x and y are co-primes, x and y over here are co-primes, right? X and y over here are co-primes. Now it's given co-prime means that the HCF of x and y is 1. If you assume that HCF of x and y is 1, then the HCF of 33x and 33y will be 33. Now their sum is 528. So you can say that 33x plus 33y, that is equal to 528. Let's simplify it further. So 33 you can take as common from here. You'll get x plus y, that is equal to 528. So from here you'll get x plus y to be equal to 528 divided by 33. 11 3s are 33. Then you see 4 and then 8. So this will be 16. So we have got x plus y to be equal to 16. So you want x and y as unique numbers such that their sum is 16. So let's start with it. Suppose you've got x over here and y over here. So we want the sum to be 16. So you can put 1 and then 15 over here. Now you can just increase them. You see 2, 3, 4, 5, 6, 7, 8, 9, 10 and so on. And then you can just decrease them. So this will be 14, 13 and then you see 12 and then you see 11, 10, then you take 9, then 8 and then you'll get 7 and then you'll get 6. Now you just start thinking from here. You see over here, this was 7, 9 and then you see 9, 7, 10, 6 is coming. You see over here 6, 10, 7, 9. So 9, 7, 6, 10, 6. So these will not come because over here order does not matter. We want unique pairs. So whether you write x plus y or y plus x, it is the same thing. So therefore this will not be counted. You see 9 plus 6 is 16, 9 plus 7 is 16 and 10 plus 6 is also 16. Now start from here, we want co-prime pairs. You see 1 and 15 are co-prime numbers because their HCF is 1 only. They are not co-primes because their HCF is not 1. They are co-primes, they are not co-primes, co-primes, not co-primes, co-primes, not co-primes. So just see that patiently once again, 1, 2, 3, 4. So you can say there are 4 such unique pairs or you can say 4 such unique numbers whose sum is 528 and their HCF is 33. So 4 will be the answer. One of the important questions on this topic. Now let's see the other thing. The question is if the product of two numbers is this and their HCF is this, then you have to find their LCM. Now this property you know that product of HCF and LCM of two numbers is equal to the product of the numbers itself. This is valid for two numbers only. It's not valid for 3 numbers. So don't use this result for more than 2 numbers. For 3 numbers, another result is there which is not in the syllabus, right? So product of 2 numbers is this and their HCF is given. So you have to find the LCM. So product of 2 numbers is 5780. That is equal to the product of the HCF and the LCM. So you can just calculate from here. You can just calculate from here that LCM will come out to be equal to 5780 upon 17. And then if you will calculate, you will get 340 only. You will get 340 only. So basically assertion is correct over here. Now the second statement is HCF is always a factor of LCM. That is also correct. HCF is HCF of whether 2 numbers, 3 numbers or any number of numbers is always a factor of the LCM, or you can say LCM is a multiple of HCF. You can think that as well taking examples. See, HCF is the factor of, suppose you are taking 3 numbers. HCF is the factor, LCM is the multiple. So obviously the factor of each of them will also be a factor of the multiple of all of them. That's common sense. So that is also true. HCF is always a factor of LCM. But over here you see assertion is true and reason is also true. But over here you see assertion is not the correct explanation of reason is not the correct explanation of assertion. So therefore you will say option B is correct over here. So this is one of the important questions in this chapter. Now you see last category of questions I'm not proving actually. I'm not proving actually because the proof you have seen, but I'm just showing you over here that this is one of the important questions in this chapter. proofs of irrationality, whether they can ask prove that root 3 is irrational, or they can ask 3 plus 2 root 5 to be irrational, prove that root 2 plus root 5 to be irrational. I have already proved them in the actual classes as well on the Infinity Learn class 9 and 10 YouTube channel. So that's all we needed to do. We needed to discuss over here in five important questions on the chapter real numbers. Don't forget to like, share and subscribe to the Infinity Learn class 9 and 10 YouTube channel. Thanks for watching.